Hey everyone, so here's a video showing how to actually use this formula that I explained in the previous video. Okay, so basically this says find the derivative at a point. Okay, so it says find this little apostrophe. Okay, this apostrophe basically means derivative, that little apostrophe. So find the derivative at 4. Okay, basically find the derivative at x equals to 4. So x equals to 4, okay, is right over here. Okay, so we're basically trying to find the derivative of this tangent line right here. Okay, of that tangent line right over there. Remember, the tangent line is a line that touches only one point in the graph. A secant line is one that touches two. Okay, and again, we're trying to find the slope. When asked for derivative, we're talking about tangent lines. So we're trying to find the slope of this tangent line. Okay, right here. Okay, that's what we're trying to find. All right. Okay, and we're trying to, and that is at x equals to 4. Okay, you can see it's 4 right there. Okay, I just wrote it bigger. Okay, so now we're just going to plug it in this formula here. Okay, so we are basically plugging in 4s for the x's right there. Okay, I meant to do that in red. Okay, we're basically plugging in 4s here because of that 4. All right. If they can also word it, they could have also worded the problem as find the slope or derivative. This is another way they could have worded it. Find the slope or derivative of the graph at the function at the indicated point x equals to 4. Okay, in that case you would plug in the 4 just like you see here. Okay. So as of right now, okay, you should understand that line right there. Okay, that line. Okay, and from here on out, okay, the game from here on out, this is basically IM2 material. Okay, you're basically substituting and then simplifying, and then hopefully you can cancel this h on the bottom. Okay, so we're substituting here. Okay, we're substituting, I'll do it in blue. Okay, 4 plus h. We're substituting that into x. Okay. And later on, we're substituting 4 into the x. Okay. So when you substitute, okay, 4 plus h into this function, you are basically going to get this right here. Okay, let's see if I can. You're basically going to get that. Okay, that's when you substitute 4 plus h into this function. When you substitute 4 into the function, you are going to get this right here. Okay. And then when you do a double-double distribution, okay, when you do a double-double distribution here, okay, 4 plus h distributed, you're basically going to get, okay, let me use this yellow highlight here. You're basically going to get this right here. So these two yellow highlights match. Okay? And the way they got this 32 is simplifying all of these numbers. Okay? Let me just double check that. 2 times 4 squared is 2 times 16, which is 32. 32 minus 3, okay, becomes 29. Okay, so now we have -3 minus 29, which brings us to -32. Okay, so this became these blue highlights became the -32. Okay, and then all they did was just distribute the 2. Okay, distribute the 2. Boom, boom, boom. And then combine like terms. The 2 times 16 is positive 32 minus 32 becomes 0, so that cancels. Okay, so that lands us at this point. We're here. And then you can divide everything by h. Okay, all right. You can think of it because you can basically rewrite this. You can rewrite this as 16h over h. You can basically rewrite. Let me just shut up and. Okay, you can basically rewrite this as that. Okay, and these h's cancel. Okay, and if you have two h's on top, one h on bottom, you're left with one h on top, and therefore you get this. Okay, you get this right here. Okay, now we're interested in what happens as h approaches 0. Okay, as h approaches 0. And you plug in 0 for h, and you get 16. So, long story short, the slope at x equals to 4, okay, is 16. Okay, the slope at x equals to 4 is 16. Okay, a slope at x equals to 4 is 16. Now, in a little bit, the next example, it's gonna ask you the slope of. It's just gonna give you a general x here. Okay, what happens if it is the slope of f of x? Okay, and then they're going to ask for it's not going to be an actual number, okay, as your slope. In the end, it's going to be some kind of equation. Maybe it looks like I'm making something up, plus 4. Okay, so now we found a slope at a specific x value, which is 4. But later on, they want to expand it and ask for the slope of any x value. Okay, any x value, and then because they want something more flexible, not just at 4. They want a slope of any x value, and then you would come up with some kind of equation or a formula, so to speak, of the slope of any x value. Okay, that's what we're going to get to next. All right, so here, let's go ahead and look here. All right, first and foremost, these two are exactly the same thing. Okay, it's just a different way of saying the same thing. This is the derivative of x. This is the change in y over the change in x, which is basically rise over run, which basically is slope, which basically is derivative. Okay, they mean the same exact thing. All right, so let's go ahead and look at this. Okay, let's look at this guy right here. Now, again, they just copied this formula right here. All right. Okay. That's all they did. All right. Now, well, let me actually explain it this way. Before, we used to plug in, in our previous problem, this was 4. Okay, these were all 4s. Okay, but now they are all x's, because remember, they don't just want the derivative. They don't want the derivative or slope of just 4. They want it at any x value. So that's why these become x's instead of 4. They want something more flexible, more general. Okay, so we are going to plug in, okay, x plus h into the function, which is x squared. We're also going to plug in x into this function called x squared. Okay, and then when you plug in x plus h into x squared, you get this. Okay, when you plug in x into x squared, you get this. Okay, when you double distribute this blue, you get that. Okay, let me circle that better. Okay, and there's nothing to distribute here with the green. It just stays the same. Okay, x squared minus x squared cancels, and you're left with this right here. And again, the h's here, okay, you can think of it, remember, you can think of it as over h and over h. Okay, these h's cancel, and you get 2x. 2 h's on top, 1 h on bottom, you're left with 1 h on top. And we're wondering what happens, okay, when h approaches 0. Okay, just plug in 0 here, you're left with 2x. Okay, so the slope of at x of any value, at any value of x, I should say, is 2x. Okay, so this is your final answer. The slope at any value of x is 2x. So what does that mean? Okay, so the slope here at x equals to 1, well, let's plug in 2 times 1. That's going to be, all right, that's going to be 2. So the slope is 2. Okay. Now, what is the slope when x is negative 2? When x is negative 2, okay, negative 2, well, let's plug in negative 2 to the 2x. Okay, 2 times negative 2 is negative 4. So this slope is negative 4. Okay, this slope is, let me just make a bigger equal sign. This slope is negative 4. Okay, that's terrible. Let me redo this. Okay, the slope is negative 4. All right? Okay, so any value of x, the slope of any value of x, just plug in that x value into 2 times that x value and you get the slope. Okay? Now let's do this one here. This one involves fractions. Okay, this is the last example. Okay? Now, again, it used to be 4s that we plug in right here. Okay, it used to be 4s that we plug in right here. Okay, if it makes it easier, anywhere you see dy over dx, which is change in y over change in x, you can just think of it as f of x. Okay, or derivative of x. You can just rewrite it as this if you want, derivative of x. Okay, ignore that dot right there. Okay, so remember, instead of, this used to be 4, okay, that used to be 4, but now it's going to be, we're asking just for general x's. Okay, so we're plugging in, okay, x plus h into, all right, 1 over x. Okay, we're plugging x plus h into this x. Here we are plugging in x, okay, into the x right there. All right? So now the blue becomes this, and the green becomes this. All right? And then you just combine you just combine the fractions using LCM. Okay, this is missing. This is basically missing an x. And what you do on bottom, you got to do on top. This is basically missing an x plus h. What you do on bottom, you do on top. All right. And then you're going to get x. Okay, this becomes, this basically becomes that, and this becomes that, and the denominators combine. Okay, the denominators combine to become this right here. Let me use a green highlight. Okay. All right. Okay. And they're going to rewrite this. This is going to rewrite this divided by h into times 1 over h. Just like divided by 5 is the same thing as multiplying by 1/5. Okay. All right. And the x's cancel. Okay. The x's cancel. Okay, because x minus x is 0, and the negative gets distributed to h, and that's how they got negative h over here. Okay. All right. Okay. And also, and lastly, the h's also cancel here. So now you're left with negative 1 over x, okay, over x times x plus h. And as h approaches 0, okay, this basically goes away and you're left with -1 over x squared. Okay, so this is your final answer. Okay, so again, let's test this out. What is your slope, okay, at x equals to 1? Okay, let's pick a different number. Yeah, let's use 1. What's your slope at x? Let's make it a little bit more interesting. What's your slope at x equals to 2? What is your slope? Okay, what is your slope here? Okay, man, it's really tough to draw that tangent line here. What is the slope of that black line right there? Well, let's plug in 2. Okay, if you plug in 2 to the power of 2 is 2 squared, which is 4. 1 over 4 negative. So the slope of that tangent line is -1 over 4. Okay, long story short, in the previous slide, okay, previous example, we're trying to find the slope at a specific point, okay, at a specific x value. This whole slide is finding the slope at at any x value. Okay, all right, folks, that pretty much wraps up this lesson right here. Okay, thank you for tuning in. Let me hold on.